Good evening, guys. So let's start our today's class. Today we are going to learn about Windows Server 2012 DNS role. So before we begin our session, you should learn about. You have an idea about DNS. Do you have any idea on DNS? What is actually DNS are doing? What is the role of DNS in Active Directory or any other infrastructure? These are the common questions, and DNS is playing nowadays a major role in each and every small, mid and enterprise environment. So before we go on, in this slide we will going to make you understand about the deployment process and the configuration of DNS services. So this is the first slide and our objective of today. The subject line is deploy and configuring Windows DNS services. Our objective for this chapter is configuring Active Directory integration for primary zones, configuring forwarders, configuring root hints, manage DNS cache, and create a or PTR resource record. So we will going to learn about each and every point one by one. So this is actually our objective of today's class. So let's start with the first one. Understanding of DNS architecture. How DNS architecture is. For TCP/IP system to use these friendly host names, they must have some way to discover the IP address associated with a specific name. So, for example, suppose you are opening Google on your browser. So instead of Google, if we give you some IP address like 192.168.200.215, it is quite hard to remember. So to remove this kind of dependencies, DNS gives us the facility to identify a particular set of IP address with a particular unique name. In this early days of TCP/IP networking, each computer had a list of names and their equipment's IP address. So earlier, in older days, each computer has its names and their equivalent IP address called host tables. So when DNS is not in place, that means in 2000 or NT, at that time Windows system have a file called host file. That host file actually basically used to convert IP address into name. At that time, there were few enough computers on the building internet from maintenance and distribution of the single host table to be practical. So the thing is, if you think about a local area network, that means LAN network with 10 or 15 or 50 computers, it is quite possible to do the manual entries of host name using an IP address. But if you think about internet, in that case the host entries will no longer in place, because that will not help you to identify Google, Reddit Mail or any other public websites, because they may change their maintenance, they may change their IP address anytime, but what they cannot change is their name. And to identify the current IP address from the name, we must have a service which is known as Domain Naming Service or DNS. Today there are many millions of computers on the internet. So nowadays, in today's world, there is many millions of computers available in the internet, and the idea of maintaining and distributing a single file containing name of all of them in AppsGar. So instead of doing host updates, we need a single file or table where they can update the entire computer's host name with an IP address. So that is called a global DNS. Instead of a host table stored on every computer, TCP/IP network today use DNS server to convert host names into IP address. So instead of storing that records on their own host file, they are actually using DNS servers to convert the host name into IP address. This conversion process is referred to as name resolution. So this is the process which is known as name resolution process. DNS name resolution process. Okay. DNS elements. So now we are going to learn about what are the elements available in the DNS. So the first element is DNS namespace. The DNS standards define a tree structure namespace in which each branch of the tree identifies a domain. Each domain contains a collection of resources record. They contain the host name, IP address, and other information. Query operation are attempts to retrieve the specific resource records from a particular domain. So to simplify, if you can simplify it, suppose you have a domain with the name of scs.com. When you create a domain with the name of scs.com, that is also known as a namespace. Each and every domain have their own namespace and own resource details, which contains the host name, IP address, and other information like name server, PTR, etc., etc. So when a client machine tries to resolve the name of scs.com, they will request the namespace from DNS server. And if the namespace is available on the DNS server, DNS will provide the records details, that means IP address details, to the client. This is one of the critical elements in DNS, which is known as DNS namespace. Second is name servers. What is name servers? A DNS server is an application running on a server computer that maintain information about the domain tree structure and usually contain authenticated information about one or more specific domains in that structure. The application is capable of responding to the queries of information about the domain for which it is authorized, and also of forwarding queries about other domains to other name servers. This enables an DNS server to access information about the domain in a tree. So name server, what is name server? It is a special type of server role available in a DNS server, which contains the entire domain details, domain tree details and structural details, so that it can answer all the queries comes to it and help them to resolve the IP address from a host name or IP address from a name to IP address. So that is called a name server. So name server basically is similar as DNS server. Each and every DNS server who are capable to provide DNS information to the clients, those are known as name server. There is two type of name server available in the market. One is private name server, another is public name server. Private name server means those name server who can used in a local domain. like SCS.com. If you can use a SCS.com on your local domain and you created multiple records, then the local client can authenticate and get the DNS updates from the local name server, that is local DNS server. And public DNS means those DNS servers who have the entire internet database. That means entire domain which are fully qualified domain names and their entries details available in internet. That should be the server who can have that record, that is known as public name server. The next and most important element is resolvers. Resolvers, what is resolvers? A resolver is a client program that generates DNS query and sends them to a DNS server. So resolver actually the clients, okay? That means the client machine who are requesting something. So resolver is a service which generates DNS queries and send them to the local available DNS server for fulfillment. Fulfillment means for the outcome. A resolver has direct access to at least one DNS server and can also process referrals to direct its queries to other server when necessary. So each and every client machine should have at least one DNS server available to get DNS updates, and it has a feature to refer its queries to other server as on required. That means when necessary it can forward its requirement to other name server which are available in the internet or in the local network. How the DNS name resolution process works. In its most basic form, the DNS name resolution process consists of a resolver submitting a name resolution request to its designated DNS server. When the server does not process information about the requested name, it forwards the request to another DNS server on the network. The second server should generate a response containing the IP address of the requested name and return it to the first server, which relays the information in turn to resolver. As shown in this particular below figure, in this practice, however, the DNS name resolution process can be considered more complex. So this is one of the simplest process actually we have. So in this diagram, as you can see, resolver is a client machine, DNS server is your local DNS server, and authenticated DNS server is the public DNS server or any other DNS available server. A client try to resolve IP address for the domain name google.com. So resolver send the request to DNS server. DNS server check whether it has the details about the IP address of google.com or not. If not found, then it forward the same query to the authorized or authenticative DNS server. Authenticative DNS server is a DNS server which may be placed in DNS zone or may be placed outside in the internet. So once the requests come to the authenticated DNS server, it will then acknowledge the request and send the reply back to the DNS server. That means the local DNS server. Once the local DNS server resolves the IP address, able to find the IP address, then its relay or pass out the entry details to the resolver, that means the client. And in this way, the client can get resolved using a DNS server. So any name, any public domain name, any local domain name should have a DNS server to get IP address details within from a name, from a FQDN. So this is the basic name resolution process, how the name resolution process works. This is very important to understand because in modern days, all the mid and enterprise environment who are using DNS, they are also using a new feature called SSO, single sign-on. And single sign-on is a feature which is totally dependent on the DNS. Because each and everything that you are doing on your local network or LAN or public network, that always works using some DNS queries. So, to work with DNS, you should understand how the resolution process works, so that in case you face any technical challenges, you can troubleshoot the issue in proper manner and identify the root cause of the issue to resolve it proper time. So hope this is clear to all of you now. So let's move to the next slide. Now in this slide we are going to learn about DNS communications. Although all internet applications use DNS to resolve hostname into IP addresses, this name resolution process is easiest to see when you are using a web browser to access an internet site. When you type a URL contain a DNS name, for example www.microsoft.com, into your browser, the address book and press enter key, if you look quickly enough, you might be able to see a message that's saying something, finding site www.microsoft.com. Then a few seconds later, you might see a message that connecting to the site, calling by IP address. It is during the interval that the DNS name resolution process occurs. So when this is basically you can find on the Internet Explorer. If you can use Internet Explorer and try to find a new domain name, it may not be the Microsoft.com, it may be a different website. That is not an issue, but in case you doing this, you can follow that whenever you put a FQDN or a website address on the web browser, first process is it will find the site. Find the site means it has been sent the request to local DNS server. If that site has been resolved by local DNS, then you can get a quick or faster response from the local server. But if that site is not available in local server, then it can be the local DNS server can forward this request to the authenticated DNS server available in the internet or in the DMZ. So once the authenticated DNS server acknowledge the request and revert you back, once this process has complete and you as a client able to identify the IP address of the particular site, then the status will automatically change to contacting to the IP address. Okay, and during this interval DNS name resolution will work. In backend, DNS name resolution will work. Always keep in mind this communication is happened in port 53, TCP port 53. So the communication between any name server or DNS server happens on only over the port TCP53. If the port is blocked in your environment, then the DNS resolution will no longer in place. That means it will not work anymore. Keep in mind also. So this is a type of communication how DNS works. Now we are going to learn about DNS referrals and queries. This process by which one DNS server sends a name resolution request to another DNS server is called referral. Referral means server can share a request to another server. That means one DNS server can communicate with another DNS server. That the communication, that DNS server request is known as referral. Referral are essential to the DNS name resolution process. It is essential. Okay, if the referral is not being configured or not it is not working, that you may not get proper response for all the website you have entered. So referrals is essential. Okay. Second is the DNS client is not involved in the name resolution process at all. That means the end user, endpoint machine is not at all involved in the resolution process, except for sending one queries and receiving one reply. So the client machine will not involve in DNS resolution process. Resolution can be done only on the DNS server part. So what is the work of the client machine? Client can only request and receive the queries, nothing else. The client DNS server might have to send the referral to several servers before it reaches to one that has information indeed. That means, suppose you have put a Russian website abc.ru, and that may not be available in your authenticated domain server. So in that case, your local server will send a referral request to the authenticated domain server, domain naming server, and authenticated domain naming server check its record whether it has the IP address details of the website or not. If it is not available, then it can again send a referral request to any other public server. So it will find one by one until or unless it gets the record details, whatever you are asking for. By default, it will find for up to 30 seconds. Okay. If it is not resolved within 30 seconds, you will get a information on your web screen that 503 error. That means DNS server no longer responding. There is some DNS lookup error which is happening. So when it comes, once the referral unable to find the requested details on the authenticated server or the forwarded route. Type of resolution request. Now we are going to learn about what are the different type of resolution request. DNS server recognize two type of name resolution requests as follows. The first is recursive query. In a recursive query, the DNS server receiving the name resolution request takes full responsibility for resolving the name. So the DNS server will take full responsibility to resolving the name. That means if it is not resolved by the local DNS, it will give you 503 error. That means why it is happening for local websites, local domain name. Those are the type of recursive query. If the server process information about the requested names, it replies immediately to the requester. If the server has no information about the name, it sends the referral to other DNS server until it obtains the information it needs. TCP/IP client resolvers always send recursive queries to their designated DNS server. Whenever you are configuring a client machine, what you have done, you put a DNS manual entry on the DNS server tab. So when a client machine sends any DNS request to its local DNS server, that is always a recursive query, so that the client can get the maximum output of its query. So by which the recursive query means it will forward the recursive query to the DNS server. So the DNS server is the sole liable or responsible to receiving or resolving the requester's name on behalf of the resolver. Next is iterative queries. In iterative queries, the server that receives the name resolution request immediately responds with the best information it processed at that time. That means iterative queries are those type of queries. It is like a urgent request. When this query is sent to any DNS server, then that DNS server do not have any more time to forward the request to any other authenticated DNS. It will check its own database whether the query details are available or not, and immediately responds back to the requester. DNS server use iterative queries when communicating with each other. So DNS server to server communication will happen in iterative queries. In most cases, it would be improper to configure one DNS server to send a recursive query to another DNS server. That only time a DNS server does send irrelevant queries to other server. In that case, a special type of server which is known as forwarders, which is specially configured to interact with other servers in this way. Iterative queries is a different type of queries. It is basically communicating with one or more DNS servers in between the servers, not from the client server. Okay, it is a server-server communication, and basically it is why to get a faster response from locally available DNS server. And to work with this, we have another option which is known as DNS forwarders, which is specially configured to interact with other servers in this particular way. Let's learn about recursive name resolution in details. Recursive name resolution, the name resolution process described earlier in the designated to convert DNS name into a specific IP address. However, there are occasions when it is necessary for a computer to convert an IP address into a DNS name. This is called a reverse name resolution. So reverse name resolution is one of the important things. Till now we are learn about the name resolution process, that means name to IP address conversion. Now we are going to learn about reverse name resolution. So reverse name resolution means the opposite direction, that means IP to name resolution. Okay, IP address, from an IP address if we can get a name, that is known as reverse DNS resolution. The developers of the DNS created a special domain which is known as addr.arpa. So this is common for all reverse. If you can create a reverse lookup zone, you can find this address addr, that is for address, arpa. ARPA means ARP is a type of record and A is a type of record. Okay, to identify that, developers have developed this particular zone in DNS for reverse lookup, specifically designed for reverse name resolution. The in@address.arpa second level domain contains 4 additional levels of subdomains. Each of the 4 levels consists of subdomains that are named using the number from 0 to 255. Each example, the bandwidth in addr.arpa, there are total 256 third level domains which have name ranging from 0.in-addr.arpa to 255.in-addr.arpa. Each of these 256 third level of domains has 256 fourth level of domains bandwidth. Also numbered from 0 to 255 fourth level domains, 0 to 255, and each fourth level domain has 256 fifth level domains, as shown in the figure in our next slide. Each of these fifth level domains can then have up to 256 hosts in it, also numbered from 0 to 55. So this is basically, guys, don't be hesitant, because this is basically similar like IPv4 subnetting. As you can know, IPv4 have 4 octets available in the network. So this 4 octet, 3 octet can be used in class C. 3 octet can be used as a network part in class C. 1 can be host. In class B, 2 will be the network part and 2 will be the host. And class A, 1 will be network part and 3 will be the host. So this is quite like similar. Based on the entries, we can have 0 to 255. That means total 256 number of set of IPs in a particular network address, and we can set up to 3 255 domain details, and each of the domain have 255 into 255 number of clients in it. These are the basic things. To understand it better, we will have a practical class today where we are going to learn about how this works, second level, third level and all, and how the reverse, how the developer designed the reverse DNS zone with in-addr.arpa. Okay, we will learn it in our practical class so that there should not be any more doubt. So this is actually what I am trying to tell you. This is the levels. The first one is root, second one is ARPA, third one is in-addr. So if you can see in-addr, it can support 0 to 255. Each one of address available in -ADDR have 1.256.0 to 255 IP address, and each of them having IP address of similar. So these are the fifth 1, 2, 3, 4 and 5th level of IP addressing available in the DNS reverse lookup zone. Developer has designed to get maximum output of a reverse lookup. Let's learn about DNS zones. But before I move on, can you guys please tell me your doubts as of now? Do you have any doubts as of now? Please let me know. Anyone having any doubts? I got a response from Sumit. Okay, and what about rest? Let me check. Deepu do not have any doubts. Santanu do not have any doubt. Okay, great. So let me continue with the slide now. In this slide, we are going to learn about DNS zones. A zone is an administrative entity you can create on a DNS server. So zone can be created on a DNS server. For recipient, a discrete position of the DNS namespace. Administrator typically divide the DNS namespace into zones to store them on different server and to delegate their administrative to different people. Zone always consists of entries of domains and subdomains. You can create a zone that contains of multiple domains as long as there is domains are continuous in the DNS namespace. For example, you can create a zone containing a parent domain name called and its child domain name. Because they are directly connected, but you cannot create a zone controlling two different child domains without their common parent, because the two childs are not directly connected. As shown in the right hand side on the diagram, if we have cantos.com as a parent domain, we can create sales.cantos.com zone and we can create support.cantos.com zone inside it. And this is called a valid zone. But on the downstairs, there is a different scenario. It looks like similar, but if you can check with these two parts, the valid zone have two different ways. One is sales.cantos.com, which is inside a single server, and support.cantos.com is outside of this particular zone. But in the down the line, where we have seen it is invalid zone, here you can get cantos.com. Within the same zone, it creates sales.cantos.com as a host name and support.cantos.com as a host name. That means these are the A records, not the zones. Zones can be created different way, like tiles. And on the top, we have an example of parent domain and a child domain DNS zones. Just give me a minute. So now we are going to learn about the DNS zone types. The first thing is primary zone. Creates a primary zone that contains a master copy of the zone database, where the administrator make all changes to the zone resources and records. If the zone in Active Directory available only on the DNS server or a domain controller, check the box created. The server creates a primary master zone database file on the local drive. Local drive, that means on the local server where you created the primary zone. This is a simple text file that compliant with most non-Windows DNS server implementation. So the records will be saved in a text file, and it is compliant with most of the non-Microsoft OS or non-Microsoft DNS server as well. What is secondary zone? Creates a duplicate of a primary zone and another server. The secondary zone contains a backup copy of the primary master zone database and update the records on the secondary zone by replicating with the primary or master zone database file using a process called zone transfer. Okay. Next is subzone. Create a primary zone that contains a key resource that identify the authenticated servers. That means the server which is outside of your network. The subzone forward the referral request. When you create a subzone, you configure it with an IP address of the server that host or zone from which you created on the stub. When the server hosting the subzone receives a query from a name to that particular zone, it either forwards the request to the host, the zone replies a referral to that particular host, depending on whether the query is retrieved, recursive or iterative. So depending on the request, it will have the authenticated DNS details. That means the DNS owner is not me. Authenticated DNS entries will be there in the subzone, and it will forward that request to that zone depending on the query type. It may be recursive query, it may be iterative query. Okay? Let's go to the next slide now. Resource records. Now, what are the different type of records available in DNS server? The first one is SOA, Startup Authority. Okay, always keep in mind what is the SOA. It stands for Startup Authority. Indicates that the server is the base authenticative source of data connecting zone. Each zone must have a SOA record, that means Startup Authority record, and only one SOA record can be in a zone. A zone can only have one SOA record, and that SOA record defines this is the best source of the information or the data. Next is NS record, which is known as name server record. Identify a DNS server functioning as a authenticated for the zones. Each DNS server in the zone where primary, master or secondary must be replicated by a NS records. So each and every DNS server is also known as a name server. A record, A for address record. Provide a name to address mapping that supplies an IPv4 address with a specific DNS name. The record type performs the primary function of the DNS. Next is AAA record. This is also a address record, but it is for IPv6. The difference between A and AAA is A record used in IPv4 and AAAA record is used in IPv6. PTR for pointer record. Provide an address to name resolution. That means IP address to name. Okay. Mapping that supplies a DNS name for a specific address in the in-addr.arpa domain. This is the functional opposite of a record. That means it is complete opposite of a record. A record creates name to IP address conversion and PTR creates IP address to name conversion. It is used for reverse lookup only. Reverse lookup, backward lookup. Okay. Next is CNAME, canonical name. Creates an alias that points the canonical name, that is real name, of a host identified by a record. Administrator use CNAME records to provide authenticated name by which the system can be identified. Okay, CNAME is basically used to identify the exact or the original server name. MX record. MX for mail exchanger. Identify a system that will direct email traffic to a specific address in the domain or individual recipient. A mail gateway will use this MX address to identify its mail routing server or smart host server. So these are the common record which is used in DNS servers. So let's learn about the summary of today's class. Yesterday we have learned the DHCP. So just for a quick recap, I have added this point. DHCP is a sensitive DHCP is a service that automatically configures the IP address and the TCP/IP setting on the network computer by assigning the addresses from a pool. That pool is known as scope, and recycles them when they are no longer in use. That is called DHCP reservation or DHCP lease time. TCP/IP network address use DNS server to convert host names into IP addresses. This conversion process is referred to as a name resolution process. This is our today's summary. DNS consists of three elements. One is DNS namespace, one is name server and resolver. DNS namespace belongs to server, name server belongs to the DNS service available on the server, and resolver is the client machine. The hierarchical nature of the DNS namespace is designed to make it possible for any DNS server on the internet to locate the authenticated source of any domain name using a maximum number of queries. In recursive queries, the DNS server receiving the name resolution request takes full responsibility for resolving the same name. In the isolating query, iterative query, the server that receives the name resolution request immediately responds with the best information if possibly at that particular time. For internal name resolution process, the DNS function requires the DNS server has the ability to process incoming queries from resolvers and send its own queries to other DNS servers on the internet. That is called DNS forwarders. So this is all about today's session, guys. If you have any doubts and queries, please let me know so that I can answer one by one.